Hi there. Today we're going to be looking at chapter 14, topic 3. We're going to be doing two different things. We're going to be doing some definitions on sampling, and we're also going to be talking about probability. So they're like kind of two different sub things in here, but vocabulary and then application of this separate skill. So to get us ready for the random sampling definitions, we're going to consider this scenario. Before the 2005 MLB season, Major League Baseball, they instituted a new policy which included more testing and more severe punishments for players caught using performance-enhancing drugs. They decided that each player would be tested at least once every season and then be subjected to random tests throughout the season and the off-season. The reason that random testing of MLB players would be a logical method to use in this scenario is so players aren't prepared for the test, and then they can't take steps to avoid detection. But testing all players in Major League Baseball would be very time consuming and costly. Is there a better way? So here's one of our first definitions, and that is a population. A population is the, I'm going to say, entire collection of individuals you want to know about. It's everyone. Okay? So the population would be every player in Major League Baseball in this case. MLB's practice of surveying every member of a population is called a census. So a census is when you legit are dealing with everybody and you are getting information from everybody. What are some reasons that that could be difficult? Well, first of all, like they mentioned here, it could be very time consuming. There are a lot of different players, so that would take a lot of time to get everybody. It also could be very costly. You have to pay for tests for everybody. You have to pay to administer the tests, to read the tests, all that kind of stuff. And just in general, let's even think about if we were trying to get something for our class. How often is everyone showing up for class? Hard, right? So it's hard to get everyone. So in order for us to look at the results from an entire population, to do a census and get results from everyone, it doesn't seem very likely in the grand scheme of things, okay? So let's look at maybe another possibility. When we talk about a sample is a subset of the population that is chosen for study. For example, if 18% of the players who were sampled tested positive, then Major League Baseball could infer that approximately 18% of the entire MLB population would test positive as well. Okay? So instead of dealing with everybody, let's just take a percentage and sample them, and then that sample can be applied to the whole population. Now, this generalization from sample to population can only be made if each player in Major League Baseball was randomly selected. So we can't take the highest paid players, the players that show up first to practice, the ones whose last names start with A. They have to be randomly selected. And what that means is that each player has the same chance to be selected as part of the sample. And then that way there's no reason to think that players who take performance-enhancing drugs are more likely to be selected than players who do not take these drugs. So again, we can apply this idea of sample to population if our selections were random. Now, when every possible sample of the desired size has the same chance to be chosen, that sample is called a simple random sample. So for example, we could put the name of each player in a hat and draw out the desired number of players as a sample. What that means is that everyone has the same chance. Again, it doesn't matter what they get paid or what their last name is or what team they're on. Everyone in MLB has the same chance of being selected, okay? Now, the thing is that even though a simple random sample seems to be the preferred way of sampling, it wouldn't guarantee that each team in the MLB is represented. So what if the MLB wanted to ensure that each team had players being tested? Again, a simple random sample might not do that because maybe for whatever reason, the sampling that we do didn't count, like any of the Tigers, for example, okay? So if we wanted to make sure that each team is represented, we could have a different type of random sampling. When a sample is chosen by dividing the population into groups and then taking a separate random sample, this is called a stratified random sample. So it's still a random sample, it still has that validity, but what we're doing here is that we're dividing it into subgroups first. And then it's random, okay? So Major League Baseball could decide to select a certain number of players from each team to be selected. And in a stratified random sample, which this would ensure that each team would be represented and that each team would be equally represented. So this is still a type of random sample. It's just you're dividing things into subgroups first, in this case teams, and then you're being random as far as who on the team would be chosen. So let's try to put these ideas into action by looking at our example 1. Example 1 says magazines such as Sports Illustrated regularly survey professional athletes about a variety of subjects. Let's suppose that a magazine randomly selected 90 of the 360 NBA players, so that's the National Basketball Association, who were on the team's opening day roster for a survey about officiating. A asks us to briefly describe the sample and the population. Well, the sample, remember, is that special group that they're picking. And when we talk about the sample, let's just not give a number, but let's describe what it is. It's true that they're randomly selecting 90, okay? And so, but it's important to know that these are 90 players that were randomly selected. So we're going to say that the sample is the 90 players that were randomly selected. So we're telling people how big the sample is and how the sample was chosen. We're being very specific here, very deliberate in saying that it was random. Okay. So then what would the population be? Well, there were 360 NBA players. So we can say that the population is the 360 NBA players, but we can even beat that. We can be even more specific. What were these, like who was the big group of people that they were looking at? They were the players that were on the opening day roster. So the population is the 360 NBA players on the opening day roster. Okay. Now, based on what we talked about before, let's explain why it is important to randomly select the athletes for the survey. Why is it important that we mention that? And again, it's because this question has the same answer. Why do we randomly select? We randomly select to ensure that every athlete has an equally likely chance of being represented. You could say getting chosen, okay? But they have an equally likely chance of getting chosen, an equally likely chance of their opinion being represented. Okay. The next question often asks, why would we use a sample instead of conducting a census? And we said that conducting a census is difficult, right? We know that a census would be difficult to implement. It takes a lot of time, money, etc., right? So that's going to be an issue as far as that census goes. The last question says, how many different samples of size 90 could the magazine use? Well, this is going to take us back to what we did in topic 2. We have 360 total athletes that we were looking at, but we weren't choosing all 360. We were only choosing 90 of them. Now, would this be a permutation or a combination? A permutation is when order matters, and a combination if it's just the group that we're looking at. Does the order in which the athletes answer matter? I don't think so. So this is just going to be a combination. We're going to do 360 C90. And so as we learned the other day, we'll go to 360 C90. This is indicative of scientific notation. So I'll say about 4.024 times 10 to the 86th power. Okay, and that would be the number of samples of size 90 that the magazine could use in this situation. That's crazy. That's such a huge number. Lots of different groupings possible. One last example before we move on to probability. Let's decide if each of the following scenarios represents a simple random sample or a stratified random sample. And then we'll find the number of different samples that could be taken in each context. So this says a professor numbers his students from 1 to 200 and randomly selects 40 of them. So he has 200 students and he's randomly selecting 40. A simple random sample is when everyone has the same chance to be selected. A stratified is when you divide them into subgroups first. Well, it doesn't seem like this professor divided them into subgroups. He was just choosing 40 at random. So this is going to be a simple random sample. And so let's take a look. We have 200 total. He's selecting 40 of his students. And again, I don't think the order matters, so this is just going to be a combination. So let's find 200 C40. And that gives me about 2.050 times 10 to the 42. And that's how many different groups of 40 are possible. That's such an insane number, but there are that many different groups of 40 students that could be selected. Okay. Now the second one here says from a group of 100 employees, the manager randomly selects 12 of the 60 women and 8 of the 40 men to form a sample of size 20. Well, it's true that we have 100 employees and that we have a sample of size 20. But what is this manager doing before she selects those 20? We have different subgroups. What we're doing is we're taking 12 of the 60 women and 8 of the 40 men to form a sample of size 20. So because we're dividing it into subgroups, this is going to be a stratified random sample. Okay, and again, that's because we had subgroups first. Okay, so let's take a look at what's happening. We're surveying women and men. Let's take a look at the women part of this. The women part, we're taking 12 of the 60 women. So that means that we have 60 women and we're taking 12. Again, the order doesn't matter. Now let's take a look at what's happening with the men. We have 8 of the 40 men. So we have 40 men and we're choosing 8 of those. And means we should do what to these? Well, the other day we said that in this probability unit, and means that we will multiply. So let's put this in. We're going to have 60 C12 times 40 C8. And that's going to give us about 1.076 times 10 to the 20th different samples that are possible that this manager could use. Again, this is a huge number of samples. Remember that we're moving this decimal over 20 places. So that's a really large number of samples that are possible. So that's a little bit about the vocabulary about random sampling. Now I'd like to move on to probability so that we can kind of use what we did in the other lessons with permutations and particularly with combinations to help us with these probability things. I think we've all heard of probability before. We know that to find probability, we take the number of desired outcomes and we divide that by the number of total possible outcomes. Or sometimes we'll say like favorable over total, something like that. Remember, probability of an event is always between 0 and 1, okay? And we are going to round probability to the nearest thousandth, which is 3 decimal places. And we'll practice interpreting probability as well. But let's talk about making the probability first. Okay, sorry. So let's look at this first example for the probability portion. It says a coach has 12 players on a basketball team, which includes 5 guards and 7 forward centers. To avoid an unbalanced lineup, the coach wants to choose 2 guards and 3 forward centers for her starting lineup. What is the probability that out of all the lineups the coach could select, the coach selects a lineup with 2 guards and 3 forward centers? Now, you guys, we've dealt with this question before. And what we did before is that we found the number of ways that the coach could create a lineup with 2 guards and 3 forward centers. Well, now we're dealing with this idea of probability. And so this probability means that we're going to have a fraction. What we want is we want this idea of she wants to choose 2 guards and 3 forward centers. So she wants 2 guards and 3 forward centers. That's our desired amount. That's what we're going to focus on finding. But for probability, we want to divide that by all the possibilities. So the thing is that it says out of all the lineups that she could select, all the lineups she could select means that she could pick any 5 players, right? She could have 5 guards or 5 centers or 4 and 1 or any combination of that, right? That's how we're going to set up our probability. So let's look at the idea of finding the number of ways that we could get 2 guards. Well, once again, we've got 5 guards and she wants to choose 2. So that means we're going to have 5C2. The order in which she picks them doesn't matter. It's a combination. We do use combination a lot more than the permutation for these questions. And now we have 7 forward centers, and we're choosing 3 of them. So that's going to be 7C3. Now, and once again, and means that we're going to multiply those different things together. Now, as far as any of the 5, that disregards the subgroups. So altogether, she had 12 players on the basketball team. And again, she's picking a total of 5 players. So our denominator is going to be 12C5. So we can find this. And to be honest, you could put this whole thing in the calculator because of the way multiplication and division works. We don't really need parentheses, but just to be dramatic, I will do that. I'm going to take 5C2 times 7C3, and then I'll divide that by 12C5. Again, because it's all multiplication division, I don't need parentheses, but I'm just trying to show you that here's our numerator. We're dividing by the denominator. And we get that this is about 0.442 if we round to the nearest thousand. That 9 bumps that 1 up to a 2. So we see that this is about 0.442 or 44.2%. That's what we have for probability. Now, had we just found the number of ways, let me delete this part of it here. Let me just start over. If we just did 5C2 times 7C3, oh my gosh, 5C2 times 7C3, we would get a number 350. That doesn't make sense for a probability, you guys, does it? That's the number of ways that you could pick 2 guards and 3 forward centers. But we need to divide that by the total number of ways. If we were to find that, that would be the 12C5. We would divide that by the 792, and I'll just kind of show you. That's what happens to get that same value, that 44.2%. So remember, probability should be between 0 and 1. If you're not getting a number between 0 and 1, let's see if you're really finding the probability, okay? So then let's interpret this probability. Basically, when we interpret the probability, we're going to say if, and then we're going to insert description of our general context, which is our denominator. And our denominator here was picking any 5. Okay, so let's start that way. We can say if, and then let's discuss what our denominator is. If any 5 players are randomly selected, and again, the idea of probability is if it would happen like if we did it like an infinite number of times. So we'll just say if any 5 players are randomly selected repeatedly, which means this wouldn't be like a one-time thing, but over time, if this were to happen. And then we basically say that our numerator would occur about a certain part of the time. So our numerator was this idea of 2 guards and 3 forward centers. So I would say, okay, well, we would get 2 guards and 3 forward centers. And then we would say about, what was our answer? The probability, which we said was the 44.2%. Of the time. I wrote too big, sorry. Okay, but that's how we interpret probability. If we try to pick the denominator repeatedly, we would actually get the numerator this percentage of the time. So in this case, if any 5 players are randomly selected repeatedly, we get 2 guards and 3 forward centers about 44.2% of the time. Let's try one more that's like this, just to solidify that. It says, an advertising firm has a big proposal put together for Friday. They're putting together a committee of 5 to work on the proposal. Suppose individuals are randomly selected from a group of 8 associates, 3 executives, and 2 project managers. It wants the probability that the committee consists of 3 associates and 2 executives. So that's really what we're looking for here, right? That we know we need a probability. And so what we want is we want 3 associates and 2 executives. And to find the probability, we'll divide that by the total number. Again, they're putting together a committee of 5. So again, this just happens to be 5. It's not always any 5 on the bottom, okay? Any 5. So let's take a look here. So as far as the associates go, there are 8 associates, and we're picking 3. So that's going to be 8C3. And there are 3 executives, and we're picking 2. So that's 3C2. And means that we want to multiply those together. Okay. Now, let's look at the whole amount that they could choose from. They are selecting from this group. There aren't just associates and executives, there are also project managers. So we have 8 associates, 3 executives and 2 project managers. So that's a total of 13 to choose from. But not all the people are working at that committee. Only 5 are working on that committee. And once again, it's a group. So this is how we could find our probability. We would take 8C3 times 3C2, and we can divide that by 13C5. I didn't use the parentheses this time to show you it'll work. And if we're rounding to the nearest thousandth, that 5 tells us to bump the thousandths place up to a 1. So this is about 0.131 or 13.1%. And that would be our probability. So let's interpret this probability. If we want to try our denominator, so if, again, 5, I guess I'll call them workers. If 5 workers are randomly selected repeatedly, then what would happen? We'd get the numerator. We'd get 3 associates and 2 executives. About what percent of the time? Well, we look back at our probability, and that was about 13.1% of the time. And that's how you interpret probability. So now that we've done these two together, why don't you guys try the your turn example? In this your turn example, Indiana University has 18 females and 11 males trying out for their cheerleading team. The final team is going to be composed of 12 members. Let's find the probability that 6 females and 6 males will be on the team, and then practice interpreting your answer. Okay, take a second and see if you can do this one on your own. Okay, let's see how you did. Hopefully, you guys saw that we are going to be taking 6 females and 6 males, there are 18 females picking 6, 11 males picking 6. That's our numerator. Our denominator is picking any 12 members. There are 29 altogether. 18 plus 11 gave me the 29. Sorry, 29 altogether. And then we're choosing 12 of those. I got that was 0.165 or 16.5%. So that means that if teams of 12 are randomly selected repeatedly, we get 6 females and 6 males about 16.5% of the time. So that's a little bit about random sampling and probability. Okay, have a great day.